All right, let's solve homework exercise number 13 from section 11.3. A textbook committee is considering 19 books for possible adoption. The committee has to select 3 of 19. For further consideration, how many ways can they do this? Well, they're just selecting the book. Whether they select book A, B, C, or they select like book B, A, C, the order does not matter. It's just which 3 books are they selecting. So order does not matter. Okay, so an order does not matter. It's a combination, right? Combination. All right, so we're going to solve it with C, and we got a total of 19 books, and we're selecting 3, right? So if the formula is 19 factorial divided by 19 minus 3 factorial times 3 factorial, which then 19 factorial is 19 times 18 times 17. And then the 19 minus 3 we know is 16 factorial, right? So 16 factorials cancel. 16 down to 15 cancel, so we don't have to write them out. And then 3 factorial, of course, is 3 times 2 times 1. So our answer would simply be 19 times 18 times 17 divided by 3 times 2 times 1. Okay, so if we do that on our calculator, 19 times 18 times 17 divided by 3 factorial, 3 times 2 times 1, and we get our answer 969 different collection of books. Okay, now remember, the combination key is on your calculator, okay? So you can just go ahead and put in a total number you're working with, which is 19, and then hit the math key, and then use your right arrow to go over 3 times, and then the combination key to do a combination is number 3. So go down to number 3, highlight number 3, hit enter, and then put the number you're selecting, which in this case we're selecting 3 books, and then hit enter again, and you get your answer 969. So the formula for combination is built into the calculator, so I definitely encourage you to use your calculator. It's a lot faster and easier than doing it by pencil and paper. All right, number 14. How many different 3-letter possible words, 3-letter passwords are possible from A, B, C, D, E, F? Now, 3 letters. Now, if you pick like one password would be A, C, whatever, E. If you use these 3 letters and you put C, A, E, that is a different password, right? Order matters in password. Order matters, okay, in these, because if you switch around the order, keep the same letters, but switch around the order matters, so we know we're going to solve this with a permutation, okay, because order matters, so it's a permutation. The total number we got is 1, 2, 3, 4, 5, 6 letters, right, and we're selecting 3, so the answer is 6p3. So again, it is the number on the left factorial, and then you do 6 minus 3, the number n minus r factorial, so it'd be 6 times 5 times 4 times 3 factorial, and then 6 minus 3 is 3 factorial. The 3 times 2 times 1, 3 factorials cancel, so our answer is simply 6 times 5 times 4, okay, and that would be our answer. So do that on our calculator. 6 times 5 times 4, and we get 123-letter word passwords. Now again, permutation is on your calculator, right? Permutation, so you can simply put in the total number you're working with, which we said there were 6, and then math, and then go over to right arrow 3 times to highlight probability, and then NPR is number 2, permutation is number 2, so go down with your 1 unit down with your left arrow, hit enter, and you get NPR, then put the number you're selecting, which in this case we're selecting 3-letter passwords, so we're selecting 3, and there's our correct answer of 120. All right, very good. So both permutations and combinations you can do on your calculator. Using 11 flavors of ice cream, this is homework exercise number 15. Using 11 flavors of ice cream, how many different how many cones with 3 different flavors can you create if it's important to you what's on the top, middle, and bottom? Well, because you want what's on the top, middle, and bottom, order does matter. Picky ice cream eater, right? Order matters because you want to specify which one's top, middle, bottom. So order matters, so this would be solved with a permutation. We got a total of 11, and we're selecting 3. So our answer is 11P3. 11 permutations of 11 objects taken 3 at a time. So again, we can do the calculator will do the computations for us. So we put in the total number 11, go over to math, hit math, go over to highlight PRB, probability. Permutation is number 2, so you can just hit number 2, and then we're selecting 3 flavors, and our answer is 990. All right, very good. Number 16. An ice cream, let's do a similar. An ice cream store sells 5 drinks in 4 sizes and 3 flavors. In how many ways can a customer order a drink? Well, this one needs to be solved. You've got different choices, right? So this one, you're doing different selections, so it's going to be solved by the fundamental counting principle, okay, which says you got choices for drinks, sizes, and flavors. So for drinks, you got 5 choices. For sizes, you got 4 choices. And for flavors, you've got 3 choices, right? So then you take each of the choices, you multiply them all together, and that would give you your final number of ways to order a drink in terms of the drink, the size, and the flavor. So we got 5 choices, 4 and 3. So we're going to multiply those together. 5 drinks, 4 sizes, and 3 flavors. So we go ahead and do 5 times 4 times 3 flavors, and we get a total of 60 different ways to order the drinks. Okay, using the fundamental counting principle. Okay, number 17, a health inspector visits 4 of 7 restaurants on Monday. In how many ways can she pick 4 restaurants? Now again, she's just picking the 4 restaurants. So let's say she picks McDonald's, Burger King, Taco Bell, and Wendy's or whatever. Okay, and you've got these 4. And now at this point, you're just saying, how many ways can she pick? So we're not saying the order she's going to. So if we switch around the picks, if we switch around the order, she's still going to the same 4 restaurants, right? Whether Wendy's is first or 4th, or McDonald's is 1st or 2nd or 3rd, whatever. So order does not matter. If it was said how many ways can she visit the restaurants, then order would matter. But picking them, order does not matter. Okay, so at this point we're just going to we're going to solve it with a combination, right? And we've got 7 restaurants, total of 7, and she's picking 4. So the answer would be solved with the combination 7C4. Okay, because order doesn't matter when she's picking them. All right, so we'll let our calculator do the computations. Math 7, the total number, go over to hit math, go over to probability. Combination is number 3, get NCR, and then we're selecting 4 of the restaurants, and the answer is 35. All right, number 18. How many different committees can be formed from 6 teachers and 32 students if the committee consists of 2 teachers and 4 students? Now, we've got different groups, teachers and students, so we have to keep them separated. So we got to first do the teachers. Okay, now, what's the totals for the teachers? We're selecting 2 from a total of 6. And again, they're just serving on a committee, so order does not matter. Order does not matter, right? Because they're serving on the same committee whether they're picked first or second. So it's a combination, and it's 6 from a total of 6, and we're selecting 2 teachers. Okay, then we got to select the number of students. Again, same idea, we're selecting 4 students from a total of 32. Again, they're just serving on the same committee, so order does not matter, so it's another combination. So this time the numbers are 32 students, and we're selecting 4, so 32C4. And then to get the total committee of 6 members, we got to take the number of ways to get the teachers times the number of ways to get the students. So each one we'll do separately, and then our final answer will multiply these 2 numbers together to get the committees, to get the 6 members consisting of 2 teachers and 4 students, because we're doing students, then teachers, then students, okay? So each combination we can do on our calculator. The teachers, there's a total of 6. We're selecting 2. So math PRB, it's a combination, selecting 2. So 2 teachers from 6 is 15 different ways. Okay, then we're going to do the students. Okay, the students are, there's 32 students altogether. Again, order doesn't matter. So it's a combination. So it's NCR, and we're selecting 4 students. So 32C4 is 35,960. So that's the number of ways to get the students times the number of ways to get the teachers, which was 15. And then that gives us the total number of 6-member committees, which in this case is 539,400. Okay, so we had to do each one separately using combinations, and then we multiplied the 2 numbers together to get our answer. All right, this is your teacher, Dr. Swears. I hope you found this video helpful. If you still need more help on any of those problems, send me an email through the inbox in the Canvas course, and I will respond the first chance I get. Thank you very much.